Hello everyone, my name is Sejal Sachin Savan and today I am going to present my mini project on an AI based credit card fraud detection system. I have implemented this using machine learning, Flask and React.js. The main objective of this project is to identify whether a credit card transaction is fraudulent or safe based on transaction related parameters. This system helps improve banking security by detecting suspicious transactions in real time. So this is the main dashboard of my mini project. At the header, I have displayed the name of my mini project, which is FinSecure AI Fraud Detection Dashboard. So moving on to these analytical cards, this card displays the total number of transaction records available in the dataset used for model training and analysis. The second card represents the total number of fraudulent transactions identified in the dataset, and the third card displays the prediction accuracy achieved by the logistic regression model during evaluation. So this pie chart represents the distribution of safe and fraudulent transactions in the dataset. It basically helps visualize the proportion of fraud cases compared to the normal transactions. As we can see over here, almost 85% of the transactions are safe and 15% of the transactions are marked as fraud transactions. So moving on to the bar chart. This bar chart shows transaction frequency across different merchant categories such as food, travel, and groceries. It helps analyze the transaction activity patterns across different categories. So moving on to the smart fraud detection form section. It allows user to enter transaction details which are then analyzed by the machine learning model to predict whether the transaction is fraudulent or safe. So amount field, this field represents the transaction amount entered for analysis. The transaction hour field, this field captures the hour at which the transaction occurred. Moving on to the merchant category drop down, this represents the merchant category involved in the transaction such as food, travel and groceries. The next field is the foreign transaction field. This indicates whether the transaction is domestic or international. Moving on to the location mismatch field. This field checks whether there is a mismatch between the expected and transaction location. Device trust score. This score represents the reliability or trust level of the device used for the transaction. Transactions in 24 hours, these field basically represents the number of transactions that happened in the previous 24 hours, and the card holder age field is basically the age of the person who has done the transaction. So now let's see a demo for the same. Let the amount of transaction be 50 rupees. Transaction hour is 10 a.m. Merchant category, let it be food. So there is no foreign transaction and there is no location mismatch as well. Device trust score, let it be 90. Transactions in the previous 24 hours, let it be 2. Card holder age, let it be 45. And if we check the fraud, so the transaction is predicted to be a safe transaction as the amount that is transacted is very low. There is no foreign activity and there is no location mismatch as well. Adding on to it, the device trust score is also very high and low transaction frequency. That is, the number of transactions done in the previous 24 hours is only 2. So now let's do another demo for a fraud transaction. Let the amount be 3 lakhs. Transaction hour is 2 a.m. in the morning. Merchant category is travel. Foreign transaction, yes. Location mismatch, yes. device trust score is 80, transaction in previous 24 hours is 5, card holder age, let it be 25, check fraud. So the transaction is predicted to be fraud because there is a location mismatch. Even though the device trust score is high, the number of transactions done is huge, and the amount that is transacted is also high. So now moving on to the machine learning implementation. First, I performed data pre-processing. I removed the transaction ID column because it is not useful for prediction. Then I converted the categorical merchant categories into numerical format using one-hot encoding. After pre-processing, I divided the data set into training data and testing data. 80% of data is used for training and 20% is used for testing. For classification, I used the logistic regression algorithm. Since fraud cases are very less compared to normal transactions, the data is a bit imbalanced. So I used class weight to be balanced. This helps the model focus properly on fraud detection. After training, I evaluated the model using precision, recall, FN score, and accuracy. The recall score for fraud cases is high, which is more important because the primary objective of the project is fraud detection. After that, we save the model. So this is the app.py file. This file contains the Flask backend implementation of the project. The backend is responsible for loading the trained machine learning model which we implemented in the Python notebook. Next would be receiving transaction data from the front end, processing the input and returning fraud prediction results. Here the Flask application is initialized and COS is enabled to allow communication between the React frontend and Flask backend. So this is the app.jsx file. This file contains the React frontend implementation of the fraud detection dashboard. We have used React useState hooks to manage form data prediction results and loading states dynamically. This function updates form values whenever the user enters transaction details. When the user clicks the check fraud button, the frontend sends transaction data to the Flask Backend API using the Fetch API. Recharts library is used to create interactive pie charts and bar charts for data visualization. The prediction result is dynamically displayed on the dashboard based on the machine learning model response. The frontend provides an interactive and user-friendly interface for fraud analysis and prediction. The complete workflow of the project is: React frontend collects transaction details, Flask backend processes the request, the logistic regression model predicts fraud, and the result is displayed back onto the dashboard.